Humans have been consuming animal milk products since about 7,500 years ago, despite not widely developing the gene mutation to properly digest milk outside of childhood until around 1,000 years later. The gene that facilitates the production of lactase in the human body, necessary for processing the lactose in milk, see our video on what causes lactose intolerance for more on that one, it typically gets switched off in adolescence. Thanks to the rise of dairy as a significant nutrition source, initially largely in cheese and yogurt-type substances that could be widely consumed due to low lactose content and had a better shelf life, those who had a genetic quirk allowing them to produce lactase into adulthood, they flourished, and this mutation quickly spread throughout a relatively large percentage of the human population over the centuries. By 4000 BCE, a dairy economy existed in Central Europe, Asia, and ancient Egypt, and with it, well, came disease. Sicknesses resulting from tainted food have a long history of being an equal opportunity killer. The speculation that Alexander the Great died of salmonella resulting from tainted water, food, or possibly milk. King Henry I of England may have died from eating bad eels. Scholars think that the first Jamestown settlement may have been withered away thanks to a salmonella outbreak. Milk sickness resulting from drinking the milk of a cow that has eaten the plant white snakeroot killed Abraham Lincoln's mother. President Zachary Taylor could have died from drinking iced milk. The point here is that food-related illness was a rather common occurrence prior to Pasteur's innovation, especially milk-specific diseases. Due to its organic and nutrient-rich nature, milk is one of the most susceptible liquids to this, and only pasteurized milk is considered safe by the FDA, much to the chagrin of raw milk enthusiasts. However, there is good reason for concern here. Even with modern best practices, it's impossible to produce sterile milk, and from flora of the teat canal or udder to fecal soiling to water used to clean the milking equipment, various microbes will find their way into the milk, not all of them harmless. For centuries, milk-borne illnesses from tuberculosis to salmonella, typhoid, fever, diphtheria, and many others killed millions of people every year. Even as recently as the early 20th century, cow milk was responsible for approximately 1/4 of all food-borne illness. In contrast, today, largely thanks to strict pasteurization processes on commercially sold milk, only about 3 people die from milk-related sicknesses per year in the United States. Alright, so now the question comes to, well, how did Pasteur come up with his momentous innovation? In 1856, after being commissioned by the father of one of his students, Monsieur Bigot, to discover what was ruining a certain beetroot alcohol, Pasteur examined samples under the microscope and discovered not only spherical yeasts, but also a rod-shaped microorganism, Acebacter acerti, which it turns out converts alcohol to acetic acid. Methodically and systematically experimenting with both lactic and alcoholic fermentation, Pasteur concluded that fermentation was not the result of a spontaneous generation of chemical reactions by enzymes, the then majority view, but rather the work of these microorganisms. In 1857, Pasteur returned to the École Normale as Director of Scientific Studies and continued his research on the problem. Notably, on April 20th, 1862, he completed his first test of boiling then cooling wine to kill the souring bacteria. At about this time, Emperor Napoleon III commissioned Pasteur to save the entire French wine industry, which had become overrun by diseases that turned the wine sour or bitter. In about 1863, Pasteur inspected a variety of wineries and came to the conclusion that there may not be a single winery in France, whether rich or poor, where some portions of the wine have not suffered greater or lesser alteration. Continuing his research into heating the liquid, Pasteur, who patented his heating and cooling process in 1865, discovered that the wine could be saved from souring and the original flavor preserved by heating it to a mere 50 to 60 degrees Celsius or 122 to 140 degrees Fahrenheit. Quickly adopted by the wine industry, the general pasteurization process was not widely applied to milk until many years later, to the doom of millions of people. It should be noted, however, that like nearly every innovation, Louis Pasteur did not discover the process in a vacuum. As with almost every apparent giant leap forward, closer examination almost always reveals centuries of gradual progress and forward steps towards this revelation. For instance, some historians believe that a process similar to pasteurization may have existed as far back as the 11th century in China. In order to preserve the wine, the Chinese would fill hot clay jars with fresh wine, cover with leaves, seal with mud, and then bury in the cool soil. The first documented process of pasteurization, even though it obviously wasn't called that at the time, was in the 16th century in Japan in regards to soy sauce. In order to ship it to Europe without it spoiling before it got there, the Japanese devised a process of boiling it in an iron pot, funneling it into bottles, and immediately sealing them. Even immediately prior to Pasteur, there were a number of European scientists who helped pave the path to the discovery. An Italian priest and scientist named Lazzare Spallanzani realized that a significant degree of heat could be used to kill microbes. Then, reappearance could be prevented by hermetically sealing the jar, as opposed to using a cork, which is very porous. Parisian chef Nicolas Appert won a cash prize from the French military for his work in providing safe, boiled, hermetically sealed jars of preserved food to the army. Using the money, he opened the world's first food bottling factory in 1812, where he canned and boiled all types of food, including milk. His method consisted of boiling the glass bottle in much hotter water and for a much longer time than Pasteur would later deem necessary. Due to this, the preserved food would often have its taste altered, and the glass bottles sometimes broke. A few years later, Englishman Peter Durand devised an iron can with a thin layer of tin around the exterior that could withstand the boiling process better. While Spallanzani, Appert, and Durand all understood this worked, they didn't really understand the nuts and bolts of why. In 1862, it was Louis Pasteur who answered this question. While the science behind pasteurization may have been relatively unknown in the mid-19th century, a basic understanding of biology helps explain it. Bacteria are single-celled organisms with a cell envelope. The cytoplasm, the stuff inside of the cell like ribosomes, chromosomes, enzymes, etc., and the flagella, the part that allows the cells to attach to other things. When the temperature gets hot enough, the enzymes inside of the cytoplasm chemically change shape and are no longer able to work properly. This essentially makes the entire cell unable to function. Heat can also destroy the cell envelope, which further damages the cells. Once the offending cells are dead, it is just as important to make sure nothing can enter back in. That's why jars, cans, and anything pasteurized needs to be hermetically sealed or refrigerated, which doesn't kill cells but does slow their growth immediately after being heated for maximal shelf life. As with other products, the pasteurization process in milk is specifically tweaked to kill most offending bacteria in the liquid, though to preserve the flavor, the milk is typically not heated high enough to kill all microbes, and occasionally post-pasteurization contamination also occurs. Since the milk is not hermetically sealed, these microbes still happily feed on things in the milk and multiply. Refrigerating it simply slows this process down, but it doesn't prevent it. When milk goes bad, turns sour, it means that enough bacteria has grown in it to ferment a certain amount of the lactose, which causes the sour smell. While slightly spoiled, previously pasteurized milk won't taste good and could make one sick, the smell usually comes prior to the milk being really harmful and even potentially deadly, so all of this is rarely an issue. In the century and a half since Pasteur made his discovery, pasteurization of milk and many other liquids and foods has saved literally many millions of lives, altering human history since in unknown ways. Who knows, given the large number of lives saved in the interim, if not for this process, one of your direct ancestors may not have existed, and hence, well, neither would you. So I really hope you found that video interesting. If you did, please do hit that thumbs up button below. Don't forget to subscribe. Also, I've got another channel. It's called Top 10s. I'm going to link to that below. Please do check it out if you enjoyed this video. I think you'll also like that channel as well. And as always, thank you for watching.